Hello everyone, and welcome to the live webinar, Weaving Your Organization's Digital Thread. I'm your host, Kate McInnes, and the marketing coordinator here at engineering.com. Organizations would like to be able to create a digital thread of assets to help with false investigation, change impact analysis, design validation, and other use cases. The fragmented architecture of legacy PDM suites makes it possible to create and maintain a digital thread. A product innovation platform with integrated applications can create an enterprise-wide environment to support collaborative, multidisciplinary development of complex, connected products through the complete lifecycle. A platform can maintain connections between the resulting digital assets, connect enterprise systems, control access, respect configuration rule, and persist data for the long term. Today's speakers are John Sperling and Lisa Costa. John is the VP of Product Management at ARIS. He is responsible for defining the ARIS product roadmap and leading the product management team, which drives both standard ARIS Innovator product and ARIS Labs R&D. He is also currently serving as president of the 3D PDF Consortium. Prior to joining ARIS, John worked for Aigner, Agile, and Oracle in the PLM space. Prior to that, he worked in the aerospace industry developing engineering tools and processes at Boeing and Rockwell International for the Space Shuttle, GPS satellite, and experimental vehicles. Lisa Costa is the Community Technical Manager and has been with ARIS for over 3 years as a technical resource for the ARIS community team. She draws on her many years in the CAD, PDM, and PLM industry to support ARIS community members. If you have any questions during the presentation, please enter them into the comment section on the console, and we will get to them at the end of the presentation. With that, John, the floor is yours.
Thank you, and welcome everyone. Just to give a brief introduction to ARIS, in case you're not familiar with us, we are an enterprise PLM provider made up of PLM veterans, and we're focused on markets with complex products and processes. We are on a rapid growth path and have added some really exciting customers recently, including GE Aviation, General Motors, and more. We are innovating in terms of our technology, our deployment approach, and our business model. Product complexity has grown significantly over the last 10 years and continues to accelerate as electronics and now software dominate almost every type of product, and the Internet of Things becomes a compelling reality. But as manufacturers gear up to meet increasing market demand for complex, connected products, they face competition from tech-savvy new entrants who could undermine their businesses. As they struggle to bring new products to market, manufacturers are realizing that processes designed for a simpler era are being stretched, causing numerous quality problems and resulting in rising product recalls, warranty claims, and liability issues. In fact, they face a perfect storm of challenges, coordinating mechanical, software, and electronics engineers around the world, managing suppliers that have design authority and control critical technologies, ensuring product safety when updates occur in the field, especially software, and maintaining compliance with a maze of regulations. Take this Chevy Volt hybrid transmission, for example. It's a complete system incorporating an electronic motor/generator, an electronic transmission control unit, and complex software. This transmission system has to communicate with several other systems in the vehicle, including the battery, throttle, engine, and electrical systems. This increasing complexity is causing challenges. More than 2 decades ago, major manufacturers began implementing PDM systems to address these challenges. And as the complexity of products and business processes increased, so too did the vision. But PDM technology failed to keep pace and did not make the leap to the full vision of PLM, causing implementations to lag even further behind the requirements. So what are the critical processes necessary to turn complex products into profitable products? We call this the business of engineering, and it spans across hardware and software, supports the entire life cycle, and extends out to partners and suppliers. Because legacy PDM systems have attracted the bulk of investment, an imbalance has developed which has left the business of engineering poorly supported. ARIS believes that the right way to support the business of engineering is through a product innovation platform. Such a platform enables engineers and other users to connect to critical information, to configure information, to collaborate across disciplines and with the extended enterprise, to comply with policies and regulations, and to provide complete support of the product lifecycle through manufacturing and in service. By working within the ARIS PLM platform, data that is created and modified during the course of product development is inherently related together, giving you the ability to traverse data throughout multiple disciplines and version history. This ability to trace through related product data is known as the digital thread. The notion of digital twin, representing the full digital data set of an as-service product, is tied into this as well when the platform data spans all the way through production into service. What we're going to do now is show you a demonstration of how this actually works inside the ARIS PLM platform. Watch the demo and imagine being able to navigate through your data in a similar way. You will come away with an appreciation of what digital thread really is and how ARIS can help. We will show how digital thread applies at 3 different stages of product development. 1, when defining product content initially or creating the digital thread. 2, when managing product changes or changing the digital thread. And 3, when attempting to find information months or years later or tracing the digital thread. So Lisa, over to you.
Thank you, John. So I'm going to bring up ARIS Innovator. So where we're going to start is with our requirements document. So in our fictional company, we have a requirements documents that manage the marketing requirements for our products. The first requirements document I'm going to open up. A requirements document is really a container that has several requirements linked to it. They're set up and they can be in chapters and subchapters, but basically what they are the individual requirements that we're using for designing this particular product, which happens to be a 3D printer meeting customer requirements. I'm going to open up one of the individual requirements itself, and here you can see that the requirement, it has some text as to what the requirement is, and then it's got some links. Those links can be to files, other requirements, actual websites, but more importantly, it actually links to the parts themselves. So what we have here is we have the requirements document made up of the individual requirements, and the individual requirements linked to the parts that are helping us to meet that particular design requirement. So this is an actual part being used to meet the requirement.
A fundamental notion in ARIS is relationship. Any type of items can be related, including the items that come standard with ARIS and any new item types that you create. Relationships can be structures of like items or dissimilar items like requirements and parts, as we see here. Creating relationships is at the core of defining the digital thread.
So when I'm looking at this particular subassembly, in this particular case, there's several things I can see right away. One is that there's a change pending. I can see when I look at the bottom of the screen here that from a relationship perspective that there's a bill of material. We also have the indented bill of material. So here is an example of seeing the indented bill of material, and all of these are live links. If you're not familiar with Innovator, I could double click any of these lines and be able to get to those individual components. From a standpoint of other relationships, when it comes to an assembly or a part, there are some Office documents related to this particular assembly, as well as some CAD documents. We have an ability to visualize those without having to go to those individual components. I can actually open up and visualize using our visual collaboration and see those 3D CAD documents, as well as 2D documents like drawings and Office files. So again, being able to have those relationships and see all the related information for this particular subassembly is important. In addition, so there's far more relationships than that, and one of the ways I can see that is to view the whole structure. When I bring up the structure browser, I'm going to see all the relationships for not just this subassembly, but all the component parts below it. You can see that some of these parts are also linked to other requirements, and you can also, if I go further down, you'll see that there's also, it goes all the way down to parts that are something that we purchase, and we track the manufacturer part information. So again, that would be called AML, typically approved manufacturer list, and all of that information is here in these relationships.
Yeah, so as product data is being built out, relationship data is being created and can be viewed either in tabs or in the structure browser. These are both ways to traverse your product data to follow the digital thread.
So the other direction I can go, this is a subassembly that's actually a child of a higher level assembly and other relationships. So if I do a where used, you'll see that there's several places where this particular subassembly is used. So the first relationship I'm going to look at is the process plan. So obviously we don't just design product to have CAD files, we actually want to assemble a product and make a product to ship to our customers. So I'll open up that process plan.
The where used view is another very useful way to traverse relationships, in this case looking up to see what items connect to the item you're currently on.
So this is the process plan. It's part of our MPP application, Manufacturing Process Planning. So what you see here is the produced part is that subassembly, which we know is also part of a higher level assembly, which we'll get to in a minute. But basically we have to have a plan for how we're going to make it. So unlike other systems you may have seen before, we consider the manufacturing process plan to be the process by which we turn what is called an E-BOM, what we've been looking at before, the electronic BOM or engineering BOM, into the manufacturing BOM. So 2 ways to look at this, actually 3 or 4 ways depending how you look at it. What we're looking at here is a manufacturing bill of material. So the manufacturing bill of material, I can see certain things. If you're looking at the highlighting here, it's pointing out issues with this particular manufacturing BOM. One of them is that you can see here that there's an underconsumption of a component. So what it's saying is that the engineering BOM called out 2 of these items, but in the process plan, which is reflected in the MBOM, we're only utilizing 1 or consuming 1. So what I'm going to do is I'm going to fix that. I'm going to lock this process plan. Again, the ability to modify this process plan would be all controlled based on my permissions and what I'm allowed to do. I'm going to change this quantity to 2. When I do that, it gets rid of that reconciliation issue. You'll also see that it corrects the process plan, and what you're seeing on the right-hand side is that the work instructions are also being authored automatically. If we look at the E-BOM again for a minute, something else we can see here is that there's 2 components that haven't even been consumed in the manufacturing process plan yet. So I'm going to go back to my process plan, and I'm going to actually create another operation. I'm going to call this operation assemble printer head. And what I'm going to do is use my workbench, so of the parts. And again, these are brought in automatically by being the parts that are part of that assembly. And what I want to do is grab those 2 that weren't being consumed before and bring them into my process plan. So it's a draw. I want to grab the stepper motor, drag and drop it up here into step 60, and also the drive gear. Oops, I missed. When you drag, you need to drop. Other types of things I can have in my tool bench are tools, skills, machines. In this case, what I want to do is grab a tool, a plier in this case, and I'm going to put it and actually drag and drop that in there. When we talk about machines, skills, things like that, something else that's an element to the manufacturing process plan is that we can have different locations. You can see this location is Detroit, but we also have another location, Toulouse, so you can, the skills or the machines or tools can vary, therefore the manufacturing process plans and MBOMs can vary by location. You'll see over here it did automatically author, but in my case I want to make sure the quantity here is 2. And also on this one as well, that it's 2. So again, keep in mind what's going on here. By editing or creating this operation, it's automatically taking care of that in the E-BOM. It corrects the problem there, and it's generating a manufacturing bill of material based on that. So it's adding those parts to the MBOM itself. You'll also see that there's things like phantom assemblies that only exist in the context of the assembly and are never really modeled in our CAD model in any way in the E-BOM. So I'm going to save that and be done with my process plan for now.
All right, well, what we're seeing here is another important aspect of digital thread. Since ARIS is built on a single product innovation platform, all data inherently works together. So even more complex data model relationships, such as between EBOM, MBOM, and process plan, can be kept in sync. Trying to do this in separate systems leads to a lot of error-prone data re-entry, resulting in a broken digital thread. There's no way to do checks and balances like you've seen here.
So from the where used, the other thing that you'll notice that is linked to my process plan is a process quality document, so a PQD. I'm going to open that up right from that where used as well. So the QMS application that we have in Innovator on that single platform, like John mentioned, has two parts to it. One's called proactive quality, and the other is reactive quality, and we're going to see an example of both. This is a process quality document that's linked to the process plan. In this case, it's an environment where we are authoring three things all at in one place. We're the process control plan, a flow diagram, and a process FMEA. I'm going to lock this because I can see when I look at my process control plan, it's actually bound with that the process plan that we just edited. So what it means is that it knows that somebody's added an additional operation that should be accounted for in all three of those documents. So what I want to do now is also lock this process quality document, and what it will do is it'll let me accept that step, that operation 60, and you'll see that not only does it accept the operation, it also the tool that was there as well. So in this case, I'll also accept the tool. These blue indicators are showing me that these are not things that were typed into this control plan. They're actually linked to, in this case, the operations that are part of the overall process plan.
Yeah, what we're seeing here is a more subtle form of the digital thread, which we call binding. It allows the PFEMA, as we see here, to be maintained as a document, but with embedded links to other PLM items like process plans. When a linked item is updated, it does not immediately cause the document to update, but rather gives the user an indication and allows her to accept or reject. This also brings us to the topic of change processes. Let's see what else is involved in changing the digital thread.
So when I look at my component part, if you remember back to when we were looking at it, there was indicated there's a change pending on it. It is an affected item on an ECO. In this case, this particular ECO is also linked to the other side of the quality, the QMS package, which is the reactive quality. So a couple things I want to take a look at here. This is the corrective action plan. So at some point in time, there was an issue with this particular assembly, and actually if we take a look real quick, I know I pointed out the ability to visualize, but I'm also going to take a quick look. We actually have a discussion thread as part of that tool, the visualization tool, which is the ability to have a conversation. So if you look back on this particular assembly, you're going to see that there's some things that happened in the past. There was a issue on a test rig, which somebody took a photo, again from a tablet, and was able to put that into the system. And then there was some reaction to that about suggestions for ways to fix it, things that we should do to fix it, and also now that it's been fixed, ultimately what it would look like. So the reason I point that out is because we have this corrective action plan, which has that same problem report that was used to raise the issue, and eventually that issue we came up with a preventative action, which is that ECO. But in addition to that, the corrective action plan not only has the events that could bring forward a particular corrective action plan, in this case a problem report and a non-conformance report, it also has the ability to have the other elements of a corrective action plan: containment, analysis, corrective actions, and preventative actions. The one thing I would like to point out is that we also have that similar visualization capability. Right here you'll see that there is an attachment to the NCR, the non-conformance report, and if I wanted, I could actually see what that attachment looks like, and you can see it's another photo from a test rig of something, the fan that was not conforming to the particular requirements. And I can see that there's a 5 Whys document that was used as the analysis for this particular corrective action plan. Taking a closer look at the overall components here, the containment issues can be things like purge notices, stop ships, also hold notices. There's other types. On the analysis, you saw that we have a root cause analysis. We've already looked at the attachment for that. I'm going to open it up for 1 minute because in addition to the actual document, which is the 5 whys, it's also this root cause analysis has a cause item type link to it. So we're going to see that we're going to be able to reuse those causes a little bit later. The corrective actions that can be done, the corrective actions are for this particular quality issue, things that we're going to do. In this case, we deviated, we did a deviation, but then there's the preventative action. So the preventative action in this case was 2 things. The ECO that we saw before, which is actually going to change and revise that particular assembly and take it from revision A to revision B. But the other thing that we have here is that other side to the quality, which is that basically, yes, we had a quality issue and we want to fix it in our current product, but we also want to incorporate it into the design quality document, which is typically called the DFEMA, so that it doesn't happen in the future, okay? So in this case, what I want to do, if you think back to the cause, so during our analysis, we came up with a root cause analysis, and we came up with another cause that could happen in the motor. So what we're going to do is go over to the cause column here, and again, we come down here and say when there's excessive heat, another cause of that could be that bad fan. So what we can do here is I want to insert another cause, and again, it's going to be from a reference like we saw before, and I want to select it, and it's our low performance fan was being used. So again, we have that same indicator like we saw in the process quality document. This happens to be a reference. We saw that the cause itself is an item type that can be controlled, can be version controlled, and knows all the places where it's been used, so that you can always know when you have the particular cause, you know where it's currently being accessed by other item types.
All right. Well, changes often get driven based on quality issues coming from the field, and as we've seen, ARIS QMS covers both the proactive and reactive sides of the quality process, and as shown here, allows you to close the loop between reported root causes and DFEMAs. If these processes were in different systems, the digital thread would be broken.
All right, so going back to the change itself, so obviously change management, configuration management is kind of at the heart of everything to do with the digital thread, right? Knowing when we modify this, all the places that will be affected. When you see this particular ECO, you can see that it's changing out the fan. We've already looked at that conversation or discussion thread that we saw before, but one thing I would want to point out about our visual collaboration, it does, it's highly configurable like anything in ARIS Innovator, but what it allows you to do is have items actually come aggregate upward. So if I'm ever on the change, as you can imagine, there's some people that are on the change item that might access this assembly, like what we're about to change, that they might forget what does the extruder look like. They have the ability to visualize these documents that are actually attached. If you remember previously, these aren't attached to the ECO itself, they're attached to the assembly. But what we want to be able to do is from the change, people don't want to have to climb up and down the structure to get a full picture of everything that's going on with this change. Again, from a change management perspective, the form itself is highly, you can modify the form if you want. This particular change has an engineering document review associated with it. Because I have the green light, I know that the documents have caught up. If I want to take a closer look at that for a second, down here at the bottom, you can see that this particular, it's using our impact matrix. This particular assembly is going to be revised from revision A to revision B when it is completed and signed off. That's going to entail, let's see some changes down here. It's removing a couple items and also adding another. So again, you can visualize this several different ways. We saw one way was to see it in the discussion thread. We saw pictures taken from the actual CAD documents. Oh, and there's also CAD documents here, sorry. I kind of slid around too fast. So there's CAD documents. Those are actually the items that are related to the EDR. And again, this is optional behavior with Innovator, but it's totally up to you. If it's a different set of people that sign off on the ECO, which is the modification of the product itself, versus people that approve that the documents have caught up, you can actually spawn a different workflow which will report back into the overall change. Before I process this change, I'm just going to do one more thing. I'm going to go look at the new version, revision B of that item again, because I do want to show you there's, depending on how people think, there's multiple ways to look at this change. If I turn the redlining view on, I can actually visualize the change that's happening to this guy. I can see it as a red line. Again, that's a pretty familiar concept to people, being able to see, yes, we're swapping out a different fan, and we're getting rid of a thermocouple off of this particular assembly. So a red-lined view. Also, we saw the visualization using the 3D geometry associated with it. All of those are ways for me to feel comfortable that I personally have looked at everything around this change and understand what we're doing and feel comfortable signing off on it. I can go, this particular change is sitting in my in basket, but I can, if I'm already looking at the ECO itself, I can actually sign off on it right from this point. So I am Mike Miller, and I can vote now. Whether I pick up the item to sign off on it either from my in basket or right from this sign off tab from the ECO itself, I always get this workflow activity completion. So what this is, it's basically showing me how I'm signing off on this. And actually, I just want to do one more thing while we're here. I'm going to show the workflow, what it looks like. So if I was curious as to how the ECO got to this point, I have the ability to see where I currently am and where it's been before, who it's waiting for to sign, like we saw in the sign off tab, but also being able to see, previously, who signed off on the previous steps as well. Again, just so everybody knows where those things came from. So in this case, I am going to vote. I've vetted everything out. I've looked at the instructions. Everything has been followed. All the changes have been made, and now I want to submit it. I have two choices. If you remember back to the workflow, this particular has a step in the workflow has a branch from draft changes. I can either close it or I can submit it for another review, which would kind of do a loop around if I needed other people to put their eyeballs on it. And also, the design of the workflow itself allows for delegation, or I can refuse. These are all part of the workflow engine that we have when you're designing the setup. These are all optional. This just happens to be the case in this particular instance. So I'm going to sign off on this and hope I type my password right. Always a danger. So once I sign off on that, the actual change, the change itself is now released. So you can see it's in a release state. If we go back to the assembly itself, it's in the release state. And from that where use that we did a moment ago, part of the, if we took a look at this higher level assembly that references our little extruder subassembly, what you'll see is that it is already looking at the release version. And that's because this particular, this is a new design, the next iteration of our 3D printer, and so it has the ability to have a float relationship. Because it hasn't yet been released or locked down, it automatically adapted to be looking at the latest and greatest version of our little extruder subassembly.
Great, yeah, it's critical to understand that the relationships being managed in ARIS carry full configuration management information, such as version, revision, and lifecycle state, and more subtle aspects, such as fixed versus floating behavior that Lisa was just pointing out. Approaches that rely on simple hyperlinks to tie data from different systems together cannot have a persistent digital thread. You need full CM information.
So from this higher level assembly, which we can see here, this is our 3D printer product that utilizes our extruder head, is actually just the extruder head of a 3D printer here. There it is right in there. From here, I can do a where used. So this particular top level assembly is actually the work product or deliverable in a project itself. So there's a project associated with this new printer that we're making. So again, ARIS Innovator has another application for doing project and program management. So it is a full project and program management tool. Some of the capabilities that you'll see here is that, first of all, at the top of the screen, I have the ability to have multiple phases, and I can see how I'm progressing through those phases. It has Gantt charts, deliverables we're going to see in a minute, predecessors, scheduling, forward, backward scheduling, so all of those things. In this particular scenario, for our purposes today, you can see that there has been some market research done, and the deliverables and attachments in this case are the exact same items that we've been looking at all along, right? Office documents, the assembly, and then we see also that there's some technical documentation associated with this. So the tech docs in this case, you can see here that there's a tech doc, and this is the MakerBot packing list technical document. So here you can see it's just an authoring environment. In this case, the tech doc tool allows you to publish PDFs and web pages. But what it's doing is, instead of being a document like we've seen with the other things that were linked to our parts, this is actually managing content like a structure, right? So it's like managing it like a PLM or a PDM system, because we have reusable components, we actually can build them, we can have styles, can determine how these things should look when we reference them. So when we look further down, here you can see that this is actually referencing that extruder subassembly that we had, and it's referencing the assembly itself. And when we take a look at this in the authoring environment, it tells me that there's a newer version of this subassembly available. So it's telling me that the tech doc or the user documentation or packing list has gotten out of sync with what's going on. So much like we saw before, I have the ability, if I have the rights to modify it, I have the ability to come in here and decide that, yes, I'd like to update this tech doc to reflect the latest list of components based on that change that we just processed for our extruder. So I am going to update to the latest so I can make sure that also even my tech doc has caught up with the changes that we have in our product.
All right, well, here we're seeing a couple other applications inside ARIS, both program management and technical documentation. Again, if these applications were in different systems, the digital thread would be broken. And again, we see a type of loose binding where changes to product information will signal the technical document owner that he may want to do an update. Now let's take a look at our third topic, which is tracing the digital thread.
So now we're going to flash forward.
Into the future.
Into the future. Back to the future. So what we have is, so imagine, so obviously that whole design process was, we created the digital thread, and then there comes a day, months, years down the line, where we're coming up with a heating issue, or some product that we have has an overheating issue. So what we want to do is actually investigate that. So one way we could start out with that is to go back in time and look at previous issues or corrective action plans that we've had. So in this case, I take a look. Again, I can see that there was, like, if we're having a thermal problem now, I can look back and say, well, we did have a thermal problem in the past. What did that thermal problem actually, what was it associated with? So here you can see I can open up that corrective action plan. And then again, when we talk about these corrective action plans, which we've seen before, from here I have the ability to look at, there was a nonconformance as well as a problem report. I can go to that problem report directly to that link, and from that problem report I have the ability to get right to the parts in this case. And from the part, I can also have the relationship to those requirements that we started out the demo with. So I have the ability to go all the way back to, what did we do wrong, either the components, what did we do to fix it, but also what were the requirements themselves that we originally started out with that brought us to that particular problem in that case, and a corrective action plan. So again, that's that. If you think back to the PowerPoint that we had, we design with a digital thread, but we also have the ability to go backwards through that thread at any point in time to get back to those original documents that started us off.
Yeah, absolutely. I mean, traceability is really at the heart of the digital thread concept. Your entire company is based on the success of your product and ultimately on the intellectual property that makes up the product definition. If you have a failure, perhaps catastrophic, in the field, how quickly can you find this product definition information? How accurate will it be? How many systems will you have to traverse to find it? At ARIS, we contend that the best way to build a digital thread is in a product innovation platform, one that is flexible, scalable, and upgradable. We've seen that ARIS provides a product innovation platform that inherently supports the notion of creating, changing, and tracing the digital thread. Analysts such as SimData have been thinking about the concept of a product innovation platform for some time. SimData recently released some papers on the topic, which are listed here. And if you haven't tried ARIS, please download it free of charge from our website. You will see how easy it is to create, change, and trace a digital thread in your product data. And with that, we'll move to Q&A.
Okay, great. So we do have a question that came in. It says, how do you manage this database to ensure that it is always updated?
Yeah, well, that's a good question. As I think we tried to show here, it's all about creating, changing, and maintaining, and then being able to trace that digital thread. Obviously, the ability to do that depends on creating it in the first place. So a couple of things there. I mean, obviously, that's the bulk of the work that you're doing as a engineering organization is to work on your product data. Another side benefit of having a common platform is that, as you saw from the demo, it's all a common user interface. So once you know how to, create a part, then you know how to create a document, you know how to create a quality plan, corrective action plan, et cetera, et cetera. So usability is a big thing. We take that very seriously at ARIS. We think that making things simple, even things like 3D visualization, as you saw, and having everyone have access to that is a big part of having everyone exposed to the product data and having that product data be able to play together, to be linked, and to ultimately be able to trace that digital thread.
Great. The next question is, I already have a PLM system from another vendor. Why can't I just use that to build a digital thread?
Yeah, we kind of touched a bit on that in the slides. I think a lot of other systems may say PLM, but in fact they have a heritage of being a PDM system, and in many cases the implementation of that has stalled out probably after basic PDM capability. One thing we can do at ARIS is it doesn't mean that you have to rip and replace what you have already. We can overlay your legacy system and then tie that in to that system and other systems and help you build the complete thread that way.
Great. So the next question is, my PLM vendor says they have a platform as well. I'm not really sure what the question is there.
Yeah. I guess there's different ways you can define a platform. The point is with ARIS that everything is built on the same platform. As you've seen, it shares a common process and data model, shares a common user interface. Oftentimes, vendors will acquire technology and slap a brand on it and say that that's part of their platform, but in reality, those tools can be poorly integrated or not integrated at all. They have different user experiences, different systems to be installed and maintained by IT, and so it might be a nice PowerPoint platform, but it's not really a platform.
Okay. The next one is the digital thread creation automated or at least prompted in some way, or does it rely on the discipline of well-trained users to create a complex network of links between items?
Yeah, that's kind of like the first question we took, a little bit about how do you actually create the data. It's not you don't get your product data for free. I mean, that's your job, is knowing how to create that, and of course we have integrations to things like CAD tools and Office and so forth to get the data in. But yeah, it's all about creating the data and being able to provide an environment that's friendly, easy to use, and captures it all in one place.
Great. Another question here. Is the system flexible enough to allow our company to configure workflows that are unique to our business?
Yeah, I mean, absolutely. That's part of the whole concept of a platform here. I mean, at ARIS, we believe that no two businesses are the same. It's not that we're trying to say, here's a standard out-of-the-box system and use our best business practices and go with it. What we provide is a framework and a very capable sample set of items like parts and documents and all the things you've seen here. We've been demonstrating in a standard environment. Everything you saw here is out of the box. But then you can take it further, create your own workflows, create your own items, and configure it how you like. And the nice thing about that, because we don't think of customization as a dirty word, and in fact, everything you customize in our system, because of the way our platform is built, is upgradable. And as an ARIS subscriber, we provide upgrades for free, and so as we come out with new versions of the software, you're able to upgrade your entire platform as well as all the customizations that you've made within it.
Perfect. Another question here, is there any way to try ARIS in our own environment?
Yeah, in case, I kind of mentioned this at the end, if you're not aware, we do provide an open version. The open version of Eris is available on our website for download for free. You can use that, install it, use it as long as you like, no time limit, no restriction. There are certain subscriber features such as the visual collaboration that's not included, but otherwise it's a very capable system that we have companies using that for years without paying us a dime. So if you want to become a subscriber, then you get some additional added features plus hotline support, plus upgrades and that sort of thing. So yeah, give it a try if you haven't. It's there waiting to be downloaded. It's easy to install too.
Great. Another question here: how are software components dealt with in the digital thread?
Yeah, we didn't show that as part of the demo, but certainly when we look at all the disciplines coming together, and we mentioned this at the beginning about the complexity of products. Historically, I think a lot of vendors have started with mechanical CAD, and then through electronics and electrical wiring. We have integrations for all of those. We also have integrations with ALM systems, software systems, embedded software, that type of thing. So yes, it's all critical product data, and it all really needs to come together at the point of release and locking that data down in a common configuration control, ultimately becoming what ends up is the digital twin. We didn't really talk about digital twin, but having that complete representation, and we've seen examples such as Tesla with the embedded software and the over-the-air updates that having the software be able to update that and maintain that within a platform is key and becoming even more important these days. So yeah, software and the kind of the ALM process within PLM is something that Eris is very serious about.
And I had software parts in the higher level assembly. I just didn't show them. Sorry.
Sorry, Lisa.
Okay, another question here. How do you support digital thread where elements are in other systems, as opposed to mastering everything in Eris, for example, in ERP, etc.?
Yeah, great question, and that's important. It's important to understand we're not saying that with the Eris platform that everything has to be in one monolithic system. We understand that you have other systems. As I mentioned earlier, if you have like an existing PDM system, like for CAD data management, you can tie that in through Eris. The way we do that is through what we call federation. So you can easily federate data from one system to another and actually have that data, like items and properties, be visible in Eris, but pointing to other systems, and essentially make Eris, sort of one term we have for it is the backbone of the enterprise data backbone, and tying into other systems, because yes, we realize that no one is coming to PLM clean slate. You have other products, even things like PDM that are very close but need to be tied in. So yes, we do that all the time. The very common customer request and part of an overall digital thread platform environment.
Great. We have a question here from Mike. There's actually a couple. So the first one is, how do you handle ITAR digital threads, and can you discuss handling ITAR versus non-ITAR data? And
yeah, so it's ITAR. So ITAR, I understand there are security requirements around ITAR and about data access. So we didn't get into some of the details today, but we do have a variety of data access control. So we have standard permissions. We also have actually a capability we just added in our latest release, which we call MAC policy, which is a way to control data access by matching your access level with the level of the data that you're trying to access, and that's on top of our standard security. So yes, we work with a number of companies or government agencies that have these types of requirements, and please contact us if you have further questions. That's definitely something we support.
Yes, we have ITAR customers, but we can't tell you who they are.
Thanks, Lisa.
Okay, another question here. Can you highlight broad cost of implementing a digital thread? Do I need to work with a solutions partner to integrate this at my company?
Well, that's a pretty broad question, I would say. As I said, what you saw Lisa demo is actually our standard product. There was really nothing customized there. In fact, that's our standard demo that we show for the 3D printer. And right away, if you just implemented Aris out of the box, you would have digital thread capability. It really depends on things like we mentioned about tying into other systems through federation, adding other applications for areas that are not part of our standard product, which you can easily do. And at that point, we can get our consulting services involved, either consulting or internal to Aris. We also have a number of partners that we work with worldwide that can help deploy Aris and fill out the suite to match your needs for your own digital thread.
Great. Another question came in. When you don't have an existing PLM system, but have everything in Excel, Access, and other types of tools, where do you start to fill up Aris with your data? Is it done piece by piece or in a big bang way?
Yeah, we kind of have a joke inside Aris that our biggest competitor is Excel. So we feel your pain. What I can say is, again, if you haven't tried us, you can't beat the cost. You can try us for free. You can start to experiment and get familiar and try to figure out, is it, oftentimes people start with parts and bombs, a good place to start, or maybe doc management even, or project management, some of our basic areas that are very common within PLM.
Yeah, and we also we use a agile deployment methodology, so we do actually usually have a phased deployment, so piece by piece, I guess would be another word for phased, and we deploy with the product lends itself very well with getting out functionality into the user's hands and then adding on to that functionality. And as John mentioned, a lot of our customers start with some core functionality, then add on later. It's not usually a big bang approach, everything all at once. It is a piece by piece, or either application by application, or whatever's most important to you first, and then moving on to other things that'll make your business better.
Yeah, the point being is depending on the staffing you might have in-house, the size of your company, you can do it on your own if you like, and we provide that for you to try and use as long as you want. But as Lisa mentions, we have consulting services and partners that can work with you on an agile deployment if you choose to go that route and bring in our expertise. But yes, it's always, we're looking at, we have discovery workshops, we look at what your needs are and figure out a way for best impact. We like for you to get rapid payback and acceptance and build the excitement in the company for something that's going to be actually usable, and then go from there.
Fantastic. Okay, so that looks like all the questions for today. To our audience, if you came in late or you'd like to see this webinar again, it will be available on engineering.com within 24 hours. Thank you to all who joined us, to Aris for sponsoring this webinar, and to John and Lisa, our presenters. I think that wraps us up for today. So thank you all, and we'll see you next time.